Have you ever wondered how we landed upon using the number system that we currently use? Well, I can't give you the complete story, but I can give you some ideas. So one of the ways that we can think about it is to learn really what the difference is between our numeration system and some of the other ancient systems. It's pretty common to use what we call an additive numeration system in the ancient days, and it's still kind of a natural thing. Here are two examples of what we call additive numeration systems. Additive in the sense that if you look at the symbols that we'll be using, you just simply add the numbers together or the symbols together to find the total value. So in Roman numerals, as an example, they had different symbols to represent different number values. So they used an I to represent 1. They used a V to represent 5. They used an X to represent 10. An L represented 50. And then they just kept getting larger. A C would represent 100. And that would go on and on and on. So one of the problems with the system is the numbers got larger. They had to create new symbols. So with an additive system, if you wanted to create the numbers that aren't represented here, you would just write the letters next to each other in descending order and add those together. So an example would be, if I wanted 7, I could do 5, V, I, 5 plus 1 plus 1 would give me a total of 7. And then V, I would be 8. Now, when the Romans got to 9, they might have originally used V and I, but eventually they realized that was inefficient. And if they flip the digits so that the smaller number or digit is in front of the larger, they would use subtraction. So 9 would be 10x, take away 1. And the way you take away a 1 is put it to the left. That would be 9, and then x would be 10, and then xi would be 11. And so on. So this was inefficient for a lot of reasons. If you wanted to write the number, let's say you wanted to write 377, it would look something like this: 100, 200, 300, 50, 60, 70, 5, 6, 7. And look at how many symbols are required to write a number that we can write in 3 digits. So that's kind of expired, but something that we still do use, and it's very useful, are tally marks. Tally marks is also an additive system. This is something we would use if we were trying to keep track of a number and it was ongoing in the process. We might do something like this: 1, 2, 3, 4, and every 5th mark diagonally: 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and so on. And those tallies would help us keep track. So that's a pretty good system, and it works just like the Roman numeral system, but it's also inefficient if you have lots and lots of tally marks. We currently do not use that kind of system. We use what's called a positional numeration system, and what that means is we have a set of digits, but where the digit is located or what its position is determines its actual value. So the one that we'll teach or we learn in school, and if we become teachers, we teach as a base 10 system. So when we write the digits 3, 5, 6, the student is supposed to learn to recognize that it's not a 3 and a 5 and a 6 only, but really the position matters. So we would have 3 in the hundreds place, and we would have 5 in the tens place, and we would have 6 in the ones place. And really the value of this number can be thought of as 300 plus 50 plus 6, or 356. Backing out even further, it's really 3 hundreds plus 5 tens plus 6 ones. And so we're looking at other numeration systems in this class to kind of think more about our own base 10 that we use. So for example, in a base 5 system, and remember that base 5 doesn't have 10 digits like base 10. It only has, I'll write them down here, the digits are only 0 through 4. It only has 5 unique digits. So if I were to use those digits to write a number, for example, if I wrote 3, 1, 4, I would be saying it's 3, 1, and 4, but then I would have to determine 3 what, 1 what, 4 what. So in base 5, this is the ones place, this is the fives place, this is the 5 times 5, 25s place. So the reality is the value of the number, I'd have 3 of the 25s, I'd have 1 of the 5s, and I'd have 4 of the ones. If I wanted to find the total value of this number in base 10, I would have to add all of that up. 3 25s is 75. plus 5 more is 80, plus 4 more, I believe, is 84. And so what we learned is 314 in base 5 is the same number as 84 for us in base 10. In general, to close this out, if we have any base, I'll call that base B. The way that we can create the number or think about the value of the number is the first place will be the ones place. Whatever base we're in will be the B's place. Example, base 8, that'll be the 8th place, right? And then B squared's place, B cubed's place, and B to the 4th place. And that would actually extend indefinitely to the left forever. Something to note is I didn't write the exponents at first, but really the B's place is the B to the 1st power. It's like an invisible 1. And you might remember from an algebra class that B to the 0 power can be thought of as 1. So that is the difference between an additive and a positional numeration system.